Zeros of a function. A zero is the point or points where the graph of the function crosses the x-axis. These points are also known as the x-intercepts. Sometimes we call them the roots or solutions of a function. So on a graph, this is your x-axis, this horizontal line, and your y-axis is this vertical line. So a zero is going to be the point where the graph crosses the x-axis. So at this point here, this is what we call a zero. But like the definition says, sometimes we call them roots or x-intercepts or solutions. Okay, so in the next example, we have two zeros. We have this one here, which is at x equals 3. Again, this is our zero or x-intercept, solution, or roots. They're all used to identify this point that we see on the graph. And then this side, we have x is equal to -2, and that's going to be our zero as well. In example 21b, the function of the graph is f of x equals x plus 3 times x minus 2. In this example, these two parentheses, we call them factors. The zeros of the function when inputted into the function will always give you an output of 0. For example, the zeros for this graph, as we identified up here, were at x equals 3, or we can write it as x being 3 and our y is 0, since there's no, if we go across, y is equal to 0. And on this side, we have x is equal to -1, which is -1, comma 0. So the statement above says that if we enter this 0, 3 into the equation for every x, then we're going to end up with 0. Okay. So 3 squared minus 2 times 3 minus 3, 9 minus 6 minus 3. And as you can see, it comes out to 0. So an input value is a 0 of a function if and only if the output gives you a 0. Evaluate the function at the given points and determine if the value is a 0 of the function. So to evaluate a function, we substitute what is given for x. In this case, x is equal to 2. So anywhere we see an x, we're going to substitute it with 2. And so we get -15. So in this example, the input was 2, but the output is not 0. So we say that x equals 2 is not a 0. On the next example, we have that x is 13. -13 minus 13 is -26. So again, that's not 0, so we say it's not a 0. And then the last one, we substitute -13 for x. So g of -13. Negative is positive. And so we end up with 0. So in this case, since you got 0, we say that at -13, we have a 0, which means that the graph is going to cross at that point. Let's try example 23. So h of x is equal to x squared minus 4. If h is 2, if x is 2, we substitute it. So we get 4 minus 4, which is 0. So at x equals 2, we have a 0. H of 0, let x be 0. So we get -4. So here x is equal to 0 is not a 0, because we don't get 0. -2, Negative 2 squared minus 4. 4 minus 4, which is going to be 0. So at x equals negative 2, then this is a 0. So again, all that means is if we were to graph this function at x equals 2 and x equals negative 2, the graph would cross this x-axis at those 2 points. There are many ways to solve quadratic equations. And so we're going to look at those ways. Okay. So recall that solutions to those quadratic equations are called zeros. So whenever somebody says find the solutions, they're really just looking for the zeros. A quadratic equation can be solved using the square root property, factoring, completing the square, or by using quadratic formula. So let's look at the square root property first. When x squared is equal to a, where a is a real number, then your solution is going to be x is equal to plus or minus the square root of a. And the way we get that is if x squared is by itself, we can take the square root on both sides. The square root and the 2 become a 1, or we say they cancel. And when you're taking the square root, we consider both the positive and negative solutions. And so we get a, square root of a. So the first thing you want to do is make sure x squared is by itself, which it is. So then we can take the square root on both sides. Square root and the square cancel. We use the positive and negative solution, and the square root of 25 is 5. So my two answers here is x equals 5 and x equals negative 5. And again, all that means is that if you graph, the graph is going to cross through these x-axis. Okay. The next one, solve x squared minus 9. Notice that x squared is not by itself, so first we need to isolate it. So I'm going to do that by adding 9 on both sides. So now I have x squared equals to 9, and I can take the square root. (26). Notice that the thing that is being squared is not by itself, so we need to get rid of this 2. So I'm going to do that by dividing by 2. Now here, the entire term x minus 3 is being squared, so now it's isolated. So we're going to take the square root. That cancels. So we get x minus 3 is equal to plus or minus 3. We can add 3 on both sides. So we get x is equal to 3 plus or minus 3. And from here, we have two answers. X is equal to 3 plus 3, and x is equal to 3 minus 3. So 3 plus 3 is 6, and x minus 3, 3 minus 3 is 0. So my solutions are 6 and 0. Okay, so that's how we use the square root property. Factoring can also be used. So last time we looked at factoring. And so to factor, we know we're going to need two parentheses. And that's going to be x is equal to x times x is x squared. To get the two numbers, we can take this number here, 6, and get the factors. So we have 1 times 6. Since we have a negative involved, we also need to consider the negative factors. So negative 1 times negative 6 is still 6. And then we have 2 times 3 and negative 2 times negative 3. So if we add these on the right side and the left side, 1 plus 6 is 7. Negative 1 plus negative 6 is negative 7. 2 plus 3 is 5. Negative 2 and negative 3 is negative 5. The term that we're looking for is negative 5. So that means that these two are my factors. You can check your work by multiplying x times x is x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x plus the negative 3 gives me negative 5. And negative 2 times negative 3 is positive 6. Once you have your two factors, we can use something called the zero factor property, which tells us that if you have two expressions, a times b equal to 0, then in order to get 0 here, maybe a had to be 0. 0 times b is 0. Or maybe b had to be 0. Or maybe they were both 0. Okay. So either way, what this tells us is that we can set each one equal to 0. Okay, so over here, since I have two things that are being multiplied, I can set each one equal to 0 and solve for x. And so this would be my two solutions. Again, these are just the points in the graph where the graph intersects the y-axis. In order to factor, everything has to be on the same side. So I'm going to add 2x on this side and on this side. And we always set it equal to 0. So we need two parentheses here. And then we have a negative 8. So to get a negative 8, we can do 1 times 8, negative 8, or we can do negative 1 times 8, or 2 times negative 4, or negative 2 times 4. If we add, 1 plus negative 8 is negative 7. Negative 1 times 8 is positive 7. 2 times negative 4 is negative 2. And negative 2 times 4 is positive 2. We're looking to have a positive 2. So that means we're going to use negative 2 and positive 4. Set each one equal to 0. So add 2 on both sides and subtract 4. The other way that we can solve these equations is using the quadratic formula. The quadratic formula works great. The only thing is that you would have to memorize the formula. Okay, so when something's quadratic, it means that the highest power is a 2, and the number in front of x squared is always a, the number in front of x is b, and then your constant is c. So the formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so in this example, the first thing you want to make sure to do is write everything on the same side. So I'm going to bring the negative 2x to the left. And then you can identify your a, b, and c. A is the number in front of x squared, which is 1. B is the number in front of x, which is 2. And c is the number that doesn't have the x's, which is negative 8. So to use a quadratic formula, we just substitute this. So we have negative b, which is 2, b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is negative 8, divided by 2 times 1. Simplify. 2 squared is 4. Negative 4 times 1 is negative 4. Times the negative 8 is positive 32. 4 plus 32 is 36, divided by 2. The square root of 36 is 6, divided by 2. And so we get two answers here. Well, let's just divide by 2. Negative 2 divided by 2 is negative 1. 6 divided by 2 is 3. So my answers are negative 1 plus or minus 3. And we can break that up into negative 1 plus 3 and negative 1 minus 3. So we break it up as negative 1 plus 3 is equal to 2, and negative 1 minus 3 equals to negative 4. So your solutions are x equals 2 and x equals negative 4, which is we got in the previous one using a different method. Okay, I will let you try example 30, and then if you get stuck, you can ask me during my office hours or send me an email. Solve using any method. So find the roots. Again, find the roots means zeros, or it means solutions. So since they're asking for the roots or the zeros or solutions, all we know is that y is equal to 0. Remember from the graph over here, your x is always going to be the number, and then the y is 0. So like this point is 5, 0. So y is always 0. So the first thing you want to do is let y equal to 0. Then we can determine which method we're going to use. We cannot use the square root property because we have this extra x. So we can either factor or try to factor, or we can use a quadratic formula. Factoring doesn't work all the time, and so in those cases, you would have to use a quadratic formula. I'm going to go ahead and try to factor. Negative 16 can be written as negative 1 times 16, or 1 times negative 16, 2 times negative 8, or negative 2 times 8. We need a 6, so I can see here that negative 2 plus 8 will give me that 6. So I'm going to use minus 2 and plus 8. So now I can set each one equal to 0. Add 2 on both sides, so we get x equals 2, and subtract 8 on both sides. Okay, let's try the next one. Solve. So again, solve means to find the zeros. So the first thing is let y equal 0. Okay, so one of the first things that you can try to do is factor out a greatest common factor, or you can jump in straight to factoring. But I notice here that they're all divisible by 2, so I can divide everything by 2. So 0 divided by 2 is 0. 2 divided by 2 is x squared. 8 divided by 2 is 4. And 4 divided by 2 is 2. And that makes things easier to factor, if it's possible. So here we have a 2. 1 times 2 is 2. And notice here that I cannot get any other factor, so 1 plus 2 would be 3. So that means that this is non-factorable. Okay, so you cannot factor it, but we can try to find the solution using the quadratic formula. So I'm going to have negative b. Let's write them here. A is 2, b is 8, and c is 4. So negative b is 8, plus or minus the square root of 8 squared minus 4 times a times c, divided by 2 times a. 8 squared is 64. Negative 4 times 2 is negative 8, times 4 is 32. 2 times 2 is 4. 64 minus 32 is 32, divided by 4. And you can see here that this is not a perfect number, like 25, where the square root of 25 comes out to 25. Okay, but we can still simplify it as negative 8 plus or minus. 32 can be written as 16 times 2. So we get x is equal to negative 8 plus or minus. The 16 will come out as a 4, and the 2 stays inside. Negative 8 divided by 2 is negative 4, plus or minus 2 square root of 2. Let me rewrite this here. So this will be written as 16 times 2. And again, the square root of 16 just comes out as a 4. So let's try some problems. So if 2 and negative 2 are two zeros, then find the third one. So there's two ways to do this. Number one, we can factor using the the grouping since there's 4 terms, or we can use a second method, which I'll show you right now. I'm going to work it out both ways. So we have x squared minus 3x squared minus 4x plus 12. So if you want to factor by grouping, then we can group these two together and then group these two together. So for this one, they have an x squared in common. So I can factor out an x squared. So x cubed will leave me with a 1, and x squared will leave me with a 3. And remember that for factor by grouping, our goal is to have the same parentheses. So I'm just going to write it in here. And now the 4 and the 12, they have in common a 4, so I can factor out a 4. And notice that 4x will give me the 4x, and 4 times 3 will give me the 12. So we can check the sign. This will either be negative or positive. So negative 4 times x is negative 4x, and negative 4 times negative 3 is positive 12. And so now we can say this is what they have in common, so I can factor that out. If I take this out, I'm left with x squared. And if I take this out, I'm left with 4. X squared minus 4 can still be factored as x minus 2 times x plus 2. It's a difference of squares. And all of this is still equal to 0. So now we can set each parenthesis equal to 0. And so we get x is equal to 3, x is equal to 2, and x is equal to negative 2. So the problem says if 2 and negative 2 are zeros, find the third. So we have 2 and negative 2, so this would be your third zero, x equals 3. So that's one way to work it out, is using the grouping. Now the third way is you can use in case you forget how to factor by grouping, but understanding that when it says that we're looking for a 0, that means that if you plug in this number into the equation, it should give you a 0. If that happens, then we call it a 0. So we can test them. So if I plug in a 3 for all my x's, then 3 cubed would be 3 times 3 times 3, which is 27. 3 squared is 9 times 3 is negative 27. Negative 4 times 3 is negative 12 plus 12. And so you can see that we get a 0. Since I get a 0 when I enter 3, then that means that 3 is a 0. Here we were lucky that 3 was first, but if 3 was on letter E, then you would check all of them until you find the one that gives you 0. So for example, if I enter 4, you'll see that that does not give me a 0. So 4 times 4 is 16, times 4 is 64. 4 times 4 is 16, times 3 is 48, negative 16 plus 12. So you can see that if we add these terms, we're not going to get 0. So 4 is not a 0. Okay, so you can use that if you forget how to factor by grouping. For which of the following equations are x equals 2 and negative 2 both solutions? So for this one, factoring is usually the best way to go. They're telling me that x is equal to 0, so there's 2 ways you can do this as well. First way is you can rewrite this. So since they tell you that x is equal to 2, you can plug that number into x. And so here we get 4 minus 4 minus 4, which is going to be negative 4. So that is not a solution for that problem. So then letter B was x squared plus 4 equal to 0. So 2 squared plus 4 is equal to 0. So we get 2 squared is 4 plus 4 is 8. And that's not going to work either. And so we can keep going. So the next one is C. So we plug in the 2, then we get 4 plus 8 plus 4, which is 16, so that doesn't give you 0. And so letter D, if I plug it in, 2 squared minus 4 is 4 minus 4, which is 0. So that works for x equals 2, but it has to also work for x equals negative 2. So if I plug in negative 2 here, I get negative 2 squared minus 4. Negative 2 squared is 4 minus 4, which is 0. And so you can see that letter D is the one that works for both. So now that we have this, then we can say that this is a solution. The other way to do this is to factor each of these, and then you would get the factors. So for example, if I factor letter D, x squared minus 4 equals 0. So I would have x times x and minus 2 and plus 2. And then I can set each one equal to 0. So this would give me x equals 2 and x equals negative 2. Okay. So factoring sometimes makes things a little bit faster, but if you're having trouble with factoring, then you can look at the idea of zeros. Graphs of quadratic functions, we'll look in the next video.